Hello students, welcome back to my channel again. Today we are going to learn class 12's probability chapters, probability distribution of random variable. So in the previous session I have actually completed random variable, means what is random variable, and the concept of random variable I have elaborately discussed about that. So if you want to check it out, you can go to the description box. All links related to probability chapter are given over there, so you can click on it and you will get the video. So what is probability distribution of random variable? Look at the definition that I wrote here. The probability distribution of a random variable x is defined as follows, where x can take these numbers x1, x2, xn. Probability of x according to these values, that is small p1, small p2, small pn, where pi greater than 0. Pi means all p1, p2, pn must be greater than 0. Why? Because x can be 0. The value of x can be 0. But for that 0, x's value 0, that means in sample space there is a sample point whose function's value is 0. Okay, so 0 means it is not like phi, as there is a point, so it will pi will be always non-zero, and summation I equals to 1 to n, pi equals to 1. These all pi's will be added to get the full sample space's probability, that is equals to 1. Now this particular thing for probability distribution, its general and standard notation is probability of x equals to xi equals to pi. This is the notation for probability distribution of a random variable. Now this definition means might come to you like a very typical one, but if you are getting some examples on it, then it would be more clearer. So we will be discussing one example, like tossing a coin thrice. Okay, so sample space everybody knows. These 8 are the sample point of this sample space for tossing a coin thrice. Now I'm telling that x, suppose x is number of heads. Okay, that actually you have done this particular random variable calculations in the previous session, that's why I have chosen the same one. So x number of heads. Okay, so x can take the values. What can be the values of x? For this 3, for this 2, 2, 2, 1, 1, 1, 0. That means 0, 1, 2, maximum 3. Okay, now look, this is 0. What I was telling here, that px can have the value 0. X number of heads, depending on this description or the function, x's value is 0. But look, for this value of x 0, there is a point. What is that? That is TTT. So there is a point. That means it is a singleton set. So the probability will be not equals to 0. Now probability of x. 0. How many members are here for 0? 1 member. That means probability is 1 by 8. For 1, how many members? 1, 2, 3. So it will be 3 by 8. For 2, how many members? Again 1, 2, 3. So it's again 3 by 8. And for 3, how many members? There is only 1 member. So it's again 1 by 8. Now look at the definition. All the PIs are non-zero, and if you are adding this 4, you will get 1. 1 plus 3, that means 4, 4 plus 3, 7, 7 plus 1, 8. So 8 by 8, ultimately 1. So I hope that you have understood this definition and how it is being written. Okay. So how we will be writing, not in this table form. If we want to write it individual, then we will be writing P of x equals to 0 equals to 1 by 8. Similarly, P of x equals to 1 equals to 3 by 8. P of, look, this random variable part must be in first bracket. Don't forget it. X equals to 2 equals to 3 by 8, and P of x equals to 3 is equals to 1 by 8. Okay. I hope this is clear up to this. Now look at the exercise 13.4. 13.4, question number 1, the distribution table has been given like this. So under question number whole 1, there are 4 questions. So out of them, first one is like this, and we have to check whether this is a probability distribution of a random variable or not. Okay. So we will first look at the probabilities given. First you have to see whether it is all are positive or not. It can't be 0 or it can't be negative. So these all are positive. That means for the first criteria this is valid. That means Pi is greater than 0. So this criteria valid. Okay. Second criteria is summation I equals to 1 to n. Pi must be 1. We will check 0.4 plus 0.4 plus 0.2. It's becoming 1.0, that is equals to 1. So the second point is also valid. That means this is valid for the given question. Coming to question number 2. What I told in the first question, you have to first look at the probabilities given. That must be positive, but here it is negative. So no probability can be negative. That means the given table is not valid for the question. Okay. Then coming to number 3. First look at the probabilities. They are not 0 or they are not negative. That means these are valid. Now we will be just adding these 3. Oh, one thing that if you must be thinking that -1, why ma'am has just skipped it. No, actually, because y is the random variable. It can have negative values, 0 or negative values, depending on, look, we have actually done the examples with number of something. Okay, so number of something, that's why we, maybe in your head you all are thinking that number of something can't be negative, but x can be taken, the description of x or description of the random variable can be taken as difference of two things. That also can be taken. Suppose two dice are thrown, suppose 2 dice are thrown, that means the sample space will be 1, 1, 1, 2, like this, and up to 6, 6. Now one thing in example we have actually taken that x is a sum of the numbers. Now if I am taking that x or y is difference of the numbers, then difference of the numbers, so obviously it can have anything, negative also, 0 also. So for random variable part, negative or 0, no problem with that. We will be looking at only the probabilities given, that must be positive and their addition must be 1. So let us check. First one positive. Okay, so first one is valid, second one 0.6 plus 0.1 plus 0.2, it's becoming 0.9, which is not equals to 1. That means the second property is not valid for this given table. That means this particular table is not valid for the given question. And in this way number 4 is also there. So you can, I think now you can do by your own, and we will go to the next question. Question number 2 is, an urn contains 5 red and 2 black balls. 2 balls are randomly drawn. Let x represent the number of black balls. What are the possible values of x? Is x a random variable? So look, 2 balls are drawn from the urn. Okay, so first ball and then second ball. So what are the possibilities? The possibilities are that both the balls can be black. B stands for black and R stands for red. Both the balls can be red. First ball black, second ball red, first ball red and second ball black. So there are only 4 possibilities. Now in the question it is given that x represents the number of black balls. So for this, x takes this value. Suppose this is actually s I'm giving. Then x will be, this is black balls, so 2. For this 0. For this and this both 1. That means x can take the value either 0 or 1 or 2. And these are the possible values of x. Understood? And obviously then x is a random variable because x is a real valued function functioning on the set A, S, and the range is this one. Okay, so I'm just giving the name, that is R. Understood? So this is obviously a random variable. Now question number 3. Question number 3 asks, let x represents the difference between the number of heads and the number of tails obtained when a coin is tossed 6 times. What are possible values of x? 6 times the coin is tossed. So we are not writing the sample space because the sample space will be too much long. But we can actually find the possible values of x without writing the whole sample space. Now in the sample space, we need to find out difference between the number of heads and the number of tails, right? So in the sample space, what are the possibilities of this difference? What can have of x? X can have 6 head and 0 tail, right? Now their difference, okay? Now difference, we are taking it as modulus. So the difference is 6 minus 0. Okay, so it's coming 6. Another possibility, 5 head, 1 tail, that means 5 minus 1, so it's 4. In this way, we can actually means decreasing the number of heads and increasing the number of tails. So we can have the whole sample space area. This will be 4 minus 2, that is equals to 2. Then x, it's 3h 3t will be 3 minus 3 equals to 0. X will be 2h 4t. So 2 minus 4 equals to 2 I'm taking. X is 1h and 5t. I'm taking 1 minus 5, that's minus 4, so it's 4. Then x 0h 6t, again 0 minus 6, so it's ultimately 6. So what are the possible values of x here? Here x can have the value 0, 2, 4, 6. 0, 2, 4, 6. That means these are our answers. X can have the values, possible values 0, 2, 4, 6. These are the possible values of x, and this is the answer. Coming to question number 4. This is question number 4. Find the probability distribution of number of heads in 2 tosses of a coin, number of tails in the simultaneous tosses of 3 coins, number of heads in 4 tosses of a coin. Without writing the sample space, here also we can find out in the same way like this. So here it goes for number 1. Number of heads. So x represents number of heads in 2 tosses of a coin. So what are there? X, H, that means it's actually 2 number of heads. X, then HT and TH, in both cases it is 1, and X of TT 0. So we will be writing the probability distribution like x 0, 1, 2, and P of x, that is P of 0. 0 means TT. So it will be 1 by 4. Now here are 2 elements. So for 1 it will be 2 by 4. That is half. For 2 it is 1 element, that means again it's 1 by 4. And this will be our probability distribution. Did you understand? Similarly, in number 2, we have to find number of tails in the simultaneous tosses of 3 coins. Number of tails. So what can it be? 3 coins, that means maximum 3 tails and minimum 0 tails. So 0, 1, 2, 3 number of tails. Now number of tails 0, there is only one element, that is H, you all know. So it will be 1 by 8. For 1 there are 3 elements, so it's 3 by 8. For 2 there are 3 elements, so it's 3 by 8. For 3 there is 1 element, so it's 1 by 8. Look, this probability distribution already I have discussed in the example, that's why I haven't written over here. If you are doing mainly in exam, then you must be writing it, all the sample space and all everything. I have just done the concept over here. So you need to elaborate it little bit for your exam purpose. Now this is the probability distribution for question number 2. Question number 3 tells that number of heads in 4 tosses of a coin. 4 tosses of a coin, that means number of heads So it can be like this: 0, 1, 2, 3, 4. There are the possible values of x: 0, 1, 2, 3, 4, and probability distribution. So probability distribution, number of heads, number of tails, like this you need to write down, because this maybe you don't, means you can't recall it because this is very big. So we need to write down the sample space. So this is the sample space containing 16 sample points. Why 16? Because a coin is tossed 4 times. One coin is tossed 1 time, so the outcome, number of outcomes 2. So one coin is tossed 4 times, that means 2 to the power 4, that is equals to 16. Okay, this is the formula. You all know it. So look this, you please take its screenshot so that you can at least remember this. And how you will construct it, that's very simple. I have started with 4 heads, no tail, then 3 heads, 1 tail, then 2 heads, 2 tail, and then 1 head, 3 tails, like this, and then 4 tails. And then I counted that I have not written these 2. So I have included these 2. So ultimately 16 I have got. In this way only, look, I also don't remember the whole sample space. I have constructed it. So you also can construct it if you know the process. Okay. Look, mathematics is not about memorizing. Mathematics is all about learning and learning and learning and working on it. Okay. So not working on memory. You need to work on the particular problem, not on memory. So P of x for 0. 0 means number of heads 0. Number of heads 0 only here. Okay, that is 1 by 16. Number of head 1. So 1, 2, 3, 4. That means 4 by 16. 4 by 16 means 1 by 4. Number of head 2. Number of head 2, 1, 2, 3, 4, 5, 6. 6 by 16. So it's ultimately 3 by 8. Number of heads 3. Number of heads 3, 1, 2, 3, 4. So 4 by 16, that means 1 by 4. Then number of heads 4, that is only 1. So it's actually 1 by 16. Now you can write this one as 4 by 16, this one as 6 by 16, and this one again as 4 by 16. Now you just need to add these all 5s. Look, 1 plus 4 means 5, plus 6, 11, 11 plus 4, 15, plus 1, 16. So 16 by 16 equals to 1. That means whatever we have written in the probability distribution table, we have written it correct, because this is valid. Look, their addition is coming 1. Wait, let me divide the space, otherwise you will get confused. So these probabilities values are non-zero and their addition is coming 1. That means the whole probability distribution that we have written is correct. Okay. So in this way you can do rest of the questions also. If you have any problem, then you can obviously text me. But till then, I hope that you have understood this whole topic of probability distribution. This is a very easy topic in the probability class 12 chapter. So that's all about today's session, and thank you everybody.